I'm Andrew Brandt, student athlete and engineer at Purdue University.
Luke Passano from Fort Wayne, Indiana, proud Boilermaker, Boiler Up.
Hey, I'm Benjamin Lucier, proud Boilermaker, proud American, proud member of Team 16.
Hi, I'm Philip Fryery. I'm from Buffalo, New York, and I'm a first-year engineer at Purdue.
And we're
Team 16.
Hey there, welcome to Purdue University in West Lafayette, Indiana. With over 40,000 Boilermakers on campus, traffic can get a little bit hectic sometimes. The large amount of cyclists, pedestrians, skateboarders, and vehicles can make for unsafe travel conditions. Recognizing this problem, the Purdue University Campus Safety Committee reached out to Team 16, asking us to improve the safety and efficiency of an intersection on campus. And that intersection is right here at the southwest corner of the physics building. Our team was tasked with developing a device, structure, or signage that enhances mobility, is cost-effective, uses current technology, and holds true to Purdue's aesthetic and community.
The Campus Safety Committee gave us several design constraints and criteria for us to abide by in our design solution. The constraints for our solution are that it must be cost-effective and use modern technology, while the criteria for our solution are that it must fit the campus aesthetic, increase mobility and safety, and fit Purdue's community.
To determine what safety and mobility issues exist at the intersection, we collected data on travelers passing through, recording their distraction, mode of transportation, whether they were in designated lane of travel, and whether they were involved in a near-miss incident. Upon analysis of this data, we found that vehicles and cyclists passing through the intersection were at very high risk of having a near-miss incident, with 8% of these types of travelers that we recorded having a near-miss incident at the intersection. We attributed this to the poorly implemented bike lane passing through the intersection.
To test our possible solutions, we are limited by the fact that we cannot make any actual physical changes to the intersection. This means we cannot do any physical tests, and another way must be found. We decided to use a survey to obtain data on our solutions. Our three solutions were fixing the curb being in the bike lane and straightening the bike lane, adding posts to keep traffic separated, and signs to inform cyclists to walk their bike. Our survey focused on the criteria of safety, mobility, aesthetics, and community fit. For the survey to be significant, the questions were designed to be unbiased, and the survey was sent to a diverse group of people. The average response to each question is in the graphic.
The post posed a limit on mobility in the intersection, but showed increased safety. Signage is useful for safety and mobility, but is not always used by people traveling by, and the curb increases mobility and safety without having any major drawbacks. Using survey data from Purdue students who use the intersection on a regular basis, as well as a weighted design matrix to give proper weight to more important criteria, such as increasing safety and mobility, as well as cost, we found that fixing the curb was heavily favored as the best solution.
By fixing the curb, we essentially moved taking this part and moving it in by about a foot, because as you can see, this curb right here intersects the bike lane and makes it a sort of nasty bump. We would also do that on this side of the curb, which comes in by about 2 feet instead of just being smooth. Our final part of the design solution would include straightening this bike path so that it's one uniform lane throughout the whole thing.
The main limitation of our final solution is that it does nothing to prevent pedestrians and riders from being distracted while traveling through our intersection. Additionally, it does nothing to keep pedestrians and riders in their respective lanes.
This concludes the overview for our design solution.
We hope the Purdue Safety Committee considers our ideas.
Special thanks to Dr. Nyes, Sri, and the rest of the TAs for all their help in the process.
Thanks for watching.